cubed times I4. Now to get I5th, you do I4 times I. I4 is 1. Let's continue that. I5th is I4 times I. I4 is already 1, so 1 times I, you get I again. I6, you multiply by I, you're going to get negative 1. I7, you multiply by I, you're going to get negative I. So I8 is going to be 1 again. So if you keep doing that, what do you notice? Pattern I power 4n is 1. Okay, multiples of 4 in the power, you're going to get 1 every time. So I power 4, 1, I power 8, 1. So if we do one cycle again, 9, 10, 11, 12, 1 again, I power 12, 1. 13, 14, 15, 16, 1. 1 again. So multiples of 4 will give you 1. So I power a multiple of 4 will give you 1 every time. Now we use that characteristic when we solve a lot. Okay, to simplify things. We're going to do a couple of examples to illustrate that. Okay? Yeah, good? In fact, you're going to find the application of complex numbers quite interesting if you're doing DT. Did you watch the link I posted yet? No.
I saw it this morning. The one for complex numbers?
The second one.
Oh no, not the second one.
The first one was a video. Yeah, the first one was a derivation.
Yeah, I saw that.
The second one was interesting. If you do DT, you're going to find that very interesting because it deals with machines in motion and all that. So good. Okay, so we have a look at the simplification process now. Okay, if you need to simplify I power 34, you try to get the multiple of 4 in the power. So we can write this as I32 times I. Indices I2. I power 32 is I power 4. Power 8, and I power 4 is 1. Times I squared, so you get I squared simply. And what is I squared? Negative 1. So I34 simply negative 1. Okay, we have a look at the second example. 15 I power 7 times 3 I 18. So you do 15 times 3 first, you get I 25. Okay, I7 times I18. You add the powers of indices. So you get 45I, 24 times I. Okay, I use 24 because 24 is a multiple of 4. So 45, I4, power 6 times I, and I4 is 1, so 1 power 6 times I. So 45I simply. Okay, so that's how we simplify. Example 3. This one, division. Simply 60I27 over 25I dt. Okay, can divide by 5. 12 over 5. So 12 over 5I, what?
9.
9, because 27 minus 18. 12 over 5, I power 8 times I. 12 over 5, I power 4, power 2 times I. 12 over 5 times 1 times I, simply 12 over 5, I. Okay, easy?
.4 I, right? No, I'm trying to improve my brain arithmetic.
Every time we have like an odd power, we always get like I, and given power just negative 1 straight. And if we get it, have a coefficient. So it's very simple.
You just use the property of
Yeah.
that we introduced in the beginning. Easy?
Yeah.
We'll do one example which is a bit more interesting.
Do we get to do it?
Just study it for the time being.
Like we could create a folder called Devesh's Enthusiasm.
Yeah.
No, it'll be good. It'll be good, like promotion.
Full name of the term.
Yeah, this is how you must be.
Just
if you
before
want
you graduate, we could just say that.
to, whenever you get a new HL class, you show them the video of Devesh.
Yeah.
This is how you must be if you want to succeed in HL. You see Devesh. Hey, let's do it ourselves. Yeah.
This one.
Yeah, negative power. Yeah.
Divide by
3 over 2 divided by basically 11 factorial because
Oh yes.
3 over 2 I negative 1.
Okay, English is saying we send the I power 5 on the top, but with it simplified makes it we do that here.
Okay.
So what do you suggest?
I4 times I.
Hmm?
I4 times I. You convert the I5 into I4.
We'll have I in the denominator, which still becomes I minus 1. Good idea, but you still get I negative 1 in the power. What can we do to simplify more? But you said this
Times it by instead of timesing I power 5 becomes I power 4 times I negative 1.
I power 4 times I negative 1 gives you I cubed.
No, what I meant was, if you write it as 1.5 divided by I power 5, that's 1.5 times I to the power of negative 5,
Yes.
right? You need to get that so that negative 5 becomes a positive. So you times it by another negative.
Or you times it by I over 5.
Did you modify the question?
Yeah.
Times the whole
We
thing
need to
by
simplify, but we
I5.
can't modify the question.
Yeah, you times it by
I power
I over 5.
I power I squared. I power 5I squared.
Times I5.
Did I change anything when I did it?
I3.
Yeah, but I don't change anything
No,
because
it's
I power 8 is 1. So I'm not modify the question.
Oh, right.
Okay? And times I squared times I. So I squared is minus 1. So 3 over 2 times minus 1 times I. You get negative 3 over 2 I. Okay, so we use the property that we know to simplify.
So we're allowed to do that stuff.
No, but we didn't change anything to this because I8 is 1.
It's like the when you call it rationalize a certain.
Yeah.
Take a fraction multiplied by 2 over 2. It doesn't change anything.
Yeah.
We used to multiply by root 2 over root 2. It's like multiplying by 1, which doesn't mean anything, but it simplifies things for us.
Okay. So
Good? We just do a quick intro of complex numbers, then we'll finish with that. Then you practice some questions, okay? Can you raise? Come
Yeah.
Okay, symbol for complex numbers.
that's good.
Okay. We're trying to make sure it's having that symbol before you guys leave school.
Log grand champion
You buy yourself?
in circles.
Okay, the general form is A plus BI. That's how you write a complex number in equal set. And it comes from the thing I just told you, because the point